So, we got this problem, right? And I could probably just take a picture of it. No, I'll just draw it. It's better. So, you got a cannon, and this thing is firing, like, horizontally. And it looks like we've already defined positive Y is up and positive X to the right, based on the picture.
Yeah.
And the cannon is, like, right here. Try to draw it. It's at height H. They're calling that H. And they're calling this D where it lands. And they're calling this D over 2, I guess. And they got this beautiful, oh my god, they got this beautiful, like, parabolic curve to show the path of this thing. That's cute. Okay. Mine's not perfect, but it's close. Alright. So, let's see what we're given. Okay? So I'll write my givens, like, right over here. Okay. H is 60 meters, and that's gonna mean that my delta Y is gonna be negative 60 meters. So I got that?
Well, delta Y is basically the
Displacement. Delta Y is final position minus beginning position.
Initial.
Glad you asked. And that's what that is. Okay? Because up is positive. We know it's fired horizontally, so what's the initial Y velocity?
0.
Good. We know the initial X velocity is unknown. We don't know it.
Yeah.
We know the acceleration in the X direction is
Probably positive. Yeah, 0.
we know the acceleration in the Y direction is
0, 2.
so it seems like you're a little bit confused on this. So the only acceleration we have for a projectile is downward.
The gravity.
That's why I have the negative, because up was defined as positive in our picture. And so we got 9.8 meters per second down, that's why negative. So I think those are all the things that are given. Assume the cannon is fired at t equals 0, and the cannonball hits the ground at time tg. What is the Y position of the cannonball at tg over 2? Okay, so we know the time to hit the ground is tg. We want to know the horizontal position of the cannonball. Alright. So we know it hits at height H. So I'll start off and I'll do horizontal over here and vertical here. Okay? So what? Delta X equals what horizontally? I can sketch a velocity graph.
Excellent.
What does the velocity graph look like?
Right, just straight line.
Doesn't change, right?
Yeah.
So Vx delta x
Should you mean the negative part?
is Vxt. What?
Should you mean the negative side?
No, because the horizontal velocity is this way.
Okay.
And that's positive. And we know the horizontal distance. No, we don't. We don't know the horizontal distance it goes.
It just says D.
Yeah. So we don't have the horizontal distance. Okay. And this goes with the figure. Okay. So let's go over to the vertical motion, because I can't really figure anything out with the horizontal. So that's kind of how we do it. We see what we can find out with the horizontal, see what we can find out with the vertical. So Vy versus T, initial Y velocity is 0. It's like this, right? And our acceleration in the Y direction is what?
0. Oh no, it's negative. It's negative.
Negative what? What number?
Negative 9.8.
There you go. Okay. So this is 9.8 meters per second squared. All right. So delta Y, if I look at this graph here, that's my displacement, is just going to be 1/2 AYT squared.
Because it's the area of the triangle.
Yeah, and the rest of that equation is the V naught T disappears because of this, right? So we know delta Y, we know A, we can find T, right? So we can use this to find T. And we're looking for, I'm just trying to figure out what we're looking for again. I better get organized. What are we looking for?
The position.
The Y position at T over 2. So we want this height here. And it's not necessarily half of H. Okay? We don't know what it is. Okay? We want this height here. So if this is 0, what height is the object at? So, think about something here. That's why it's 1/4. Let me pause it for a second, but it's easy. Hi.
The block here.
Okay, so let's finish this. So we know strategy. We know delta Y.
Yeah.
See, we got right there.
I know that.
We know A, Y. We got right there. So find T, right?
Okay.
So T is going to be square root of 2 delta Y over AY. Yeah? So 2 times delta Y is negative 60, right? 2 times negative 60 over AY, which is negative 9.8. So you got to tell me what this is. What's T here? I'll pause it. We multiply this out. 2 times 60. I'm just going to ignore negative because there's 2 of them, right?
So you cancel that.
So 2 times 60, and then I want to...
9.8.
Okay, so 120 divided by 9.8. 120 divided by 9.8. What did I just do? That's 12.2. Take the square root of 12.2. This is an annoying calculator. Square root of 12.2. Square root 12.2. One of those free calculators that's annoying. So it's like 3.5 seconds. Is that right? So that's the time for what?
For the cannonball to reach the ground.
Okay. And it goes a distance d.
Yeah.
All right. So 3.5 seconds is like here. That happens. This isn't a graph of y versus t or anything like that. This is y versus x. This is like a diagram. And then you got, you have to cut that in half. What's 3.5 divided by 2? It's like 1.75? So this is going to happen at 1.75 seconds. It's there. Right? So that's t at d over 2. And this is this time, right? Later when it's at d. Alright, so now I'm going to do the same thing all over again. So I'm going to just use the same mathematical model and just write 1/2 AYT squared, right? And I'm going to use this time so that I can find the displacement, right? The displacement is going to be 1/2 negative 9.8 meters per second squared times t, which is 1.75 seconds, multiplied again 1.75 seconds, and now we have to calculate it again, right? Why is it a negative? Is our displacement negative?
No.
Yeah, it is. Which way is positive?
Oh, to the right, to the
so that we, of course, be in a negative displacement. So we're trying to find out from beginning to end here, what's our displacement? And that's what we're going to get there, right? So 9.8.
Would you put 2 plus 2? Is that...
This is 1/2.
Oh, okay.
So I'm using 1/2 AYT squared. And the full equation is V naught by T, but this is 0.
Oh, okay, okay. I thought that was like plus 2. So.
Okay. Hee hee. So 9.8 divided by 2. Okay, times 1.75 times 1. Oh, no. 1.75. So we get about 15? And that's negative? Because we have a negative there? So that means I take h minus delta y, and that'll get height above ground. Above 0. You getting what I'm saying?
Yeah.
So h was 60 meters minus 15 meters, which is 45 meters, which is height of ball at 1.75 seconds, which is what time when ball
hits the ground.
No, it's the time when ball has traveled half of the horizontal distance. It's confusing.
I'm not gonna have anything left for like in the future. Oh God, leave me alone.
So that was part A. Oh my God. Let's try part B. Oh, there's my wife. Let me pause this. So next I'll do part B.